Covalency means electron sharing. Electrons sharing. Sharing of electrons talks about covalency. Is that okay? So covalent bonding, I said simply it involves sharing of an electron pair. Sharing of an electron pair, that is between two atoms. Sharing of an electron pair between two atoms. Donated by these two atoms. Donated by these two atoms to give rise to a stable configuration of the bonded species or the species involved in the bond. So in ionic bond, it involves the complete transfer of electron from one atom to another atom. But in covalency, it involves one, donation of electron, and then two, electron sharing. Is that okay? So the two atoms that are not stable, that want stability, will decide to donate their electrons. And while these electrons are being donated, they will then be shared between these two atoms together. And once the sharing takes place, it gives rise to a bond. That bond is known as the covalent bond. Is that okay? And once the sharing also takes place, the atoms involved in this bond tend to have more electrons to enable them attain stability in terms of the duplet stability or in terms of the octet stability. Is that okay? So covalent bonding involves sharing of electron pair between the two atoms, which is donated by these two atoms to give rise to a stable configuration. But please don't forget, covalency involves one, electron donation. And then two, we can talk about electron pair sharing. So the moment electron pair sharing comes in, we are talking about covalent bond or covalency. But before the electrons to be shared, there has to be donation. Is that okay? So donation and electron sharing. The force of attraction that arises when after the electrons are being donated and then are being shared between the two atoms to enable them attain stability is called the covalent bonding. Hello guys, welcome to this channel. My name is Samson and this is Chemistry with Samson. In this lesson we are going to break down covalent bonding. Okay, so now let's discuss the formation of covalent bonding. How covalent bonds are being formed. In this illustration, we are going to use what we call the Lewis dot symbol. The Lewis dot symbol. What is this Lewis dot symbol? The Lewis dot symbol is simply the symbol of an element, and then we indicate its valence electron with a dot. Is that okay? So for example, when we take hydrogen, hydrogen has the symbol capital H, and then it has one valence electron. So we are going to indicate this valence electron with a dot. This is the Lewis dot symbol. Let's take another element. Let's say chlorine. Chlorine has the symbol C and an L. So to indicate the Lewis dot symbol for chlorine, we just write the symbol for chlorine and then we indicate the number of valence electron. Chlorine has 7 valence electrons. We indicate it around the symbol of the element. So this is the Lewis dot symbol for Cl. We are going to use this to explain covalent bond formation. Don't forget that in covalent bond formation, it involves one, electron donation, and then two, electron sharing. Is that okay? Examples of compounds that exhibit covalent bonding. We can have one, H2, the homonuclear diatomic molecules especially, H2, we can have N2, we can have F2, Cl2, O2, we can also have CH4, we can also have CO2, we can have NH3, we can have H2O, etc. All these compounds here exhibit covalent bond formation. They are all examples of covalent compounds. That is, compounds that are formed as a result of covalent bonding. Is that okay? Now let's take some of these examples to explain covalent bond formation. So, using the Lewis dot symbol ideology, we are going to take our very first example. We are going to use HCl. So HCl is an example of a covalent compound that is formed as a result of covalent bonding. So what I'm going to do is that first of all, we are going to write the Lewis dot symbol for each of these elements. So I have hydrogen, and then I have also Cl. Then hydrogen has only one valence electron, but for Cl, we have 2, 3, 4, 5, 6, and then 7. Is that okay? So, hydrogen needs one more electron to be stable. Chlorine also needs one more electron in order for it to be stable. Is that okay? If hydrogen decides to transfer it one electron, it won't attain stability. Again, if chlorine also decides to transfer it one electron, it won't attain stability. So now, in order for hydrogen to be stable and chlorine should also be stable, then they all decide to donate their electron, then they all share together. Because if hydrogen donates one and chlorine also donates one, they are going to share this electron pair together, meaning that the hydrogen will have 2 electrons attached to itself, enabling the hydrogen to attain stability. And also the chlorine will have an additional electron attached to this, enabling the chlorine to also attain an octet stability. So what happens here is that this hydrogen element will donate this one electron, and chlorine also donate this one electron. So after the donation, then these 2 electrons will be shared between the hydrogen here and then the chlorine here. So it's simply like this. This hydrogen has these 2 electrons at his disposal, and then this chlorine also has these 2 electrons attached to it. Now, hydrogen has 2 electrons, enabling the hydrogen to be stable, and also the Cl has 2, 4, 6, 8, enabling the chlorine atom to also be stable. The force of attraction that arises when this electron, after it being donated, is being shared between the hydrogen and then the chlorine to enable each of them attain stability is what we call the covalent bond. So the bond here is the covalent bond. Is that okay? Another example, we can take 2 hydrogen atoms, that is H2. So one hydrogen, another hydrogen. We are using the Lewis dot symbol. So hydrogen has 1 valence electron, 1 valence electron here for hydrogen as well. Is that okay? This needs 1, this also needs 1. So they'll decide to donate 1 each so that it will be 2. Then they can all share together for them to attain stability. So there's going to be electron sharing going on here after they all decide to donate. The bond that is formed here between these 2 electrons, these 2 atoms sharing this electron pair, is known as the covalent bond. Is that okay? It's known as the covalent bond. We can also have another example. H2O. In H2O, we have 2 atoms of hydrogen and then 1 atom of oxygen. Is that okay? Hydrogen has only 1 valence electron attached to it. But for oxygen, oxygen has 6 valence electrons attached to the oxygen atom. Is that okay? Oxygen has 6 valence electrons. Each hydrogen needs 1 additional electron to be stable. This one needs 1 electron. This one also needs 1 electron. But oxygen needs 2 additional electrons to be stable. Now, how is this covalent bond formed here? So this hydrogen will decide to donate one of its electrons, and then this oxygen atom will donate this electron that is to be shared between these 2 atoms here. So that the hydrogen will have 2 electrons attached to it, enabling it to be stable. Then this oxygen will have 2 electrons attached here. Here as well, there's going to be donation from this oxygen 1 and this hydrogen also 1. So there will be electron sharing taking place over there as well. So that's what is going to happen. There's going to be electron sharing here, and then another electron sharing here. So that at the end of the day, this oxygen atom will then have 2, 4, 6, 8 electrons. It is stable. Then hydrogen will have 2 electrons attached to it. It is also stable. Is that okay? I'm using a circle to indicate the region where the covalent bond is being formed. We can simply use a dash to join the 2 electrons together this way. We can use a dash to indicate that there is a bond that is formed between this atom and then this atom, and this electrons is being shared together. Is that okay? So it will be something like this with this oxygen. So it's going to be like this. You can also do it this way to indicate the electron sharing. Is that okay? Now we could realize that this electron has been used up. This is also used up. The electrons that is used for the covalent bonding is called the bonding pair. It's called the bonding pair. The electrons that does not take part in the donation and bonding, we call them the lone pair electrons. We call them the lone pair electron. So over here we have one lone pair here and another lone pair here. Once you count to HCl in the bonding, this is the bonding pair electron. So one lone pair, another lone pair, another lone pair electron. So in covalent bonding, it involves donation and then electron sharing. But these electrons that are being donated here and that is being shared, the sharing can become unequal based on electronegativity differences between the atoms involved in the bond. And when the sharing becomes unequal, even though the sharing is taking place, but it's unequal, it gives rise to a type of covalent bond known as the polar covalent bond. And if the electron that is being donated and is being shared is this time around shared equally without any differences, it's also known as the non-polar covalent bonding. So let's discuss polar covalency and non-polar covalency as well.